In today's video, I'll show you how I turn this cheap Amazon Basic PLA into a premium filament. And it only took me a week to do so. It was a lot of work. As you can see, I have all the tests right here. But by the end of this video, you will be able not just to have a working PLA, but also save some money, almost 50% of your money, because this Amazon Basics PLA costs around 15 euros here, but I don't know in which country you are. And as we know, a Bambu Lab PLA basic filament costs around 28 euros, something like that. So stay tuned if you want to save some money and also have a working filament. Let's not waste time. Let's make it. Let's print it. Let's roll the video. Hey everyone, welcome back to my channel. My name is Alessio and this is Pixel Forge Lab. As you can see here on my bench, table, whatever you want to call it, I already had all the tests done because I already done all the tests that we needed to do. And it took me over 3 days, almost a week, to do all the tests back and forth. What I did was print some test files, for example, like the calibration cube, the health string test from Orca Slicer, another cube done with Orca Slicer with a little screw, and then the number slider, and then another tolerance test right here, and then another one right there. And that was printed with Bambu Lab PLA Basic. And then I thought to myself, why not try to make a really cheap filament working really well like a premium one? It's doable. We need just to calibrate the filament properly. So before I did that, I printed the same files, but just out of the box. And the result was pretty terrible, and you will see. One other thing that I've noticed right away was that the spool from the Amazon PLA Basics, it's too wide for the AMS, but I needed it to work with the AMS to swap the filament really quick for all these tests. So what do? In order to do that, you need to print a respooler, which it takes a while, which I did, but after I printed all the stuff. And because I needed it really quick for the test, I found a quick solution to print this respooler. And you can see right here in this clip while I'm respooling the filament, it went okay, but obviously it wasn't all roses and flowers. I had some tribulation. The filament kept slipping away, and then I broke the little nut that goes inside the drill and all that stuff. Plus, I realized after that there was still some filament left, then I couldn't respool it right away. With the respooling out of the way, it was time to dry the filament just to give a fair comparison. So I placed them inside my iBoss Polyphemus filament dryer. And you can find the review right here in the description down below or in the corner right there. And I let the filaments dry for around 4 hours. The very first thing I did was printing a first layer test with the Bambu Lab filament. And if you look closely, it turned out great. Except in the left up corner, we can see some layer issues here and there. But overall, it turned out perfect. No calibration, just out of the box, perfect Bambu Lab PLA filament. And then I printed the same filament out of the box, the Amazon Basic PLA, before calibration. And as you can see, it's literally spaghetti on a layer. It's not workable at all. It's all messed up. You can see holes everywhere. There is no consistency in the layer adhesion at all. Like you can see holes here and there, and the filaments, all the lines are not sticking together. Next up is our classic calibration cube XYZ. And let's take a closer look on the Bambu Lab one. The X side is pretty much perfect, as the Y as well, and all the other walls are perfect. The bottom layer is also perfect. There is no imperfection whatsoever, and the top layer as well. We cannot complain, and also we can take a measure as well. The calibration cube should be 20 millimeters all around, so let's measure it. On the y-axis is 1990. I don't know if you can see it. And on the x-axis is 1994. And on the z-axis is 20.03. Is 20.03. And now we take a look at the same cube, but printed with the Amazon Basic PLA before calibration. The X wall is not too bad. There's like a little crack over the X. And the y-axis is horrible. You can see almost double cracks on the surface. It's okay, it's a decent, but it's not really perfect, like the Bambu Lab one. The top layer is not really well. There's some discrepancy here and there, but it's not too bad. And the bottom layer, well, the bottom layer is pretty terrible, as we saw on the first layer as well. The lines are not connected together, and also on the edges you can see they are not close to each other, so that's really bad. And next up is Orca String Hell. And I'm surprised to say that this one was printed with the Bambu Lab filament, and there is some stringing. We can see it right there. There's some stringing at the top. Slight one, it's pretty easy to fix, but there is some stringing. And the Amazon filament before calibration, there is no stringing. And the surface, it's pretty good, except the top at the bottom, as we previously saw. I'm actually really surprised there is no stringing here. Next up is the Orca Cube with a little screw. So this is with the Bambu Lab filament. Let's check the surface first. Overall, there are some spots here and there, but I believe that it's due to the seam placed as random, and that's totally fine, and I think that's the reason. But the surface is pretty much perfect. So for the screw, we just literally screw it in and it should go smooth. As you expect from a Bambu filament, it goes in perfect. No effort whatsoever, it goes perfectly. So we can leave it like that. And now with the Amazon filament before calibration, let's check the surface. Well, it's pretty horrible. Pretty much the same as the normal cube, except it doesn't look plastic, it looks like clay. The top surface is pretty okay, but the bottom one, it's still pretty bad as the first layer. All the lines are not connected together. But now let's check the screw. It's really difficult to screw. It's really tough. So this is why it's not calibrated. And yeah, we can leave it like that. It's pretty tough, believe me. Next up is the tolerance test provided by Aurora Tech. So thank you so much for providing the model. And let's check the clearance and tolerance. Here we have the square. Let's start from really big, 0.225, and the cube goes perfectly. And then 0.2, perfect. 0.175, perfect. 0.15, perfect. And then we turn it around and we have 0.125, perfection. 0.1, still pretty perfect. And then 0.075, and this is literally the sweet spot. It just slides in perfectly. And then we have 0.05, and we should be able to clear 0.05, but let's see. It gets stuck halfway, so I would say it's a pretty tight fit, really tight. But it's a Bambu filament, so what do you expect? And now for the cylinder, we're going to do the same test from bigger to small. So here we have all the clearance, but before we're going to do that, I've noticed that we have a seam line, which is very protruded. So I'm going to file it down just a tiny bit just to make sure that the actual test is fair. I'm going to use a little file and I'm going to use this bias. And if you're interested in making this bias, I have a video right here. Check it in the description down below. From bigger to smaller. Perfect, perfect. 0.125. 0.1, I can see some friction. 0.075, this is like a sweet spot for me. And then we'll try 0.05, and it gets stuck halfway, but I think it's perfect. It's not, you can push it down and you will have a really tight fit. So we'll leave it there. And now same test for the Amazon filament before calibration. From bigger to small, we're good. We know that this one should be fine. Oh, actually, 0.15, it's pretty tight. 0.125, pretty tight. And then 0.1. Whoa, that's really, really, really hard. So 0.1 is already difficult to put in. So 0.075, I don't think it's going to go in. And in fact, it doesn't. So we're going to leave it as that. Now for the cylinder part, we're going to do the same thing again. From bigger to smaller. We know this one's fine. And then 0.125. Okay. 0.1. Okay. 0.075. It's really tight. It's really like super tight. It's like perfect fit. And then 0.05. It's really, really hard to put in. And so we're going to leave it like that. Next up is the Orca tolerance test. So it goes from 0.25, perfect, 0.20, perfect, 0.15, perfect, 0.1, tight fit, I would say. And the last one, 0.0.5. I would say it's really, really tight. So, yeah, it doesn't even come off anymore. So we're going to do the cylinder now. And this is the Bambu Lab, of course. 0.25, 0.20, 0.15, 0.1. It's really tight. I don't think we're going to get into 0.05 at all. In fact, it doesn't go in. It gets stuck right there. Next one is the Amazon Filament before calibration, 0.25. That's fine. 0.2. That's fine. 0.15. Almost perfect. 0.1. I don't think we can get in. In fact, we don't. And don't expect to get in 0.0.5. Nothing. So we're going to leave it right there. For the cylinder, I have the feeling that it's going to be the same. 0.25, 0.2, 0.15. That's the sweet spot again. And then 0.1, it won't even get in. Sort of. And then it's really hard to get out. And then 0.05, no chance. So we're going to leave it like that. And for the last test, we have the number slider. So this is the Bambu Lab filament. And yeah, the tiles are free, literally. They move super well, how they're supposed to. And we can check the surface as well. You see the bottom is perfect. All the lines are perfect. And the top is perfect as well. What would you expect? This is Bambu Lab. And again, the tiles move freely. It's perfect, literally perfect. And next up is the Amazon Filament before calibration. Let's check the clearance and tolerance. And if they slide, they are really hard to move. I say that this filament feels very, very dry. Not because I dried the filament, but it literally feels really dry. I don't know how to explain, like chalk-like. The tiles are not moving at all. This is not playable. If you want to play with this one, you cannot. It would just get frustrated and just leave it and throw it away. But let's check the surface. The surface is not too bad, except the tiles at the bottom right there is almost like the first layer we saw at the beginning, but it's not too bad. And the top layers are not that great. If you see the number 6 is not that great. The number 3 is horrible. And maybe that's why we don't have a good sliding motion right here with the tiles. So we can throw this one away. So that was fun, but that was just the beginning because we printed all the file tests with the Bambu Lab filament and then with the Amazon Basic PLA before calibration. Now we're going to jump into Orca Slicer and Bambu Studio and calibrate the hell out of this filament to make it look and work as perfect as we can. For this project, I'm going to use Orca Slicer because it has so many calibration tools like temperature, flow rate, and all those, and then pressure advance, retraction test, Orca tolerance test, and more like max flow rate, which we will do. And then you have a page for tutorials. But before we go really deep into the calibration, we're going to just do the normal calibration first, which we will find it in this tab right here, calibration, and then we will do flow dynamics and then flow rate. And then after all this, we're going to go and do all the other calibration to go really deep. So first thing first, we have our filament, and then let's sync again because I removed the other ones. Let's discard everything. Actually, let's create a new project so everything will be set to 0. Perfect. And resync again, generic PLA. I'm going to select my Amazon Basics PLA, which is a blank canvas. Is literally like a blank filament. And we go into the calibration tab and select manual calibration. If you're not familiar with this, there is no problem. You can just click on the wiki right here and it will take you to this page where you can find all about it. And this is exactly what we're going to do right now. So let's click manual calibration, select the nozzle diameter, which for me is 0.4 millimeters. And then the plate type, I have the Cool Plate Super Tack. And then finally, we're going to select our filament, which is already selected, the Amazon Basics PLA green. And I'm going to choose pattern, yes, and these values, we're going to leave them as default. Again, if you're not familiar with this, you can go to the wiki and it will tell you all about it. Just keep scrolling until you find it, and it's right here. From K value to K value and the value steps. And this pattern will be printed and we will check the value. Basically, we're going to check the lines, which corner looks best, and then we're going to type the value in the field. So let's do it. Click on calibrate. And let's do the printer do its job, and we will check the actual pattern in a bit. And now that we have the pattern printed, we need to choose which one is the best combination of lines. So we can use a magnifying glass because I am pretty much blind, so I'm going to use a magnifying glass and see which one is the best. And for me, yeah, it's the third line. Actually, it's the fourth one. 1, 2, 3, and 4. And the K value is 0.01. So we're going to go back to Orca Slicer or Bambu Lab Studio in this case because the calibration is pretty much the same, and we're going to type the value there and we can continue with the calibration. And we're going to click next and let's type the value, which was 0.01. We can keep the name of the filament as it was. We're going to just overwrite the name and we can click and finish. Flow Dynamics calibration result has been saved to the printer. Let's click OK. Well, let's go back to calibration. And let's click flow rate. And this is perfect for over extrusion or under extrusion, which we saw in the first layer was horrible. So let's click on manual calibration. And if you don't know what this one does, click on the wiki and it will take you to this page and you can read it all. It's really instructive. As you can see here, we will have to choose the nozzle diameter again, and then what kind of plate we're using, and then keep going with the instruction. And this is what we're going to print. It's going to do 2 passes, calibration 1 and calibration 2. Let's choose the plate again. Mine is Bambu Cool Plate Super Tack, the same filament, and press calibrate. So now the printer will print these 9 blocks with different flow rates. And then we will choose which one is the best one, set the value in the Bambu Studio or Orca Slicer, and we can go to the second pass, which is going to be more accurate. Here we have our 9 blocks starting from 20, 15, 10, 5, 0, -5, -10, -15, and -20. I don't need a magnifying glass for this, but I can see right away that 0 is the perfect one. All the layers are really stuck well together, but if I actually look with the magnifying glass, I can confirm that 0 is perfect. So probably we don't need the second pass. So we're going to go back in the slicer and set the value to 0. In the slicer, we click next and we select 0. We can skip calibration 2 because the block with the 0 value is kind of perfect, so we can just skip calibration 2. And we can save the filament as Amazon Basics PLA flow rate calibrated, and let's remember that, and finish. We can delete this one right here by going right there and delete. And now we have the new one calibrated. So just to be clear, we did the main calibration in Bambu Studio. Now we can go back to Orca Slicer and do the other calibrations that we don't have in Bambu Studio. And we should find our filament right here, resync, and we will reselect the calibrated filament. Now we can finally go and do all the other calibration. And by the way, if you click on tutorial, it will take you to this page where you can find all the tests. Let's click on calibration. PLA is perfect, and the range is going to go from 190 up to 230 degrees. Let's press OK. It says that we have no main fold edges. We can repair them, and we can hit slice the plate, and it's going to take 1 hour and 19 minutes, and we can just send it to the printer. After this, we're going to inspect which one is best, and we're going to set it into the filament. And here we have our temperature tower. I checked it with the magnifying glass, and I would say that 210 degrees is probably the best one so far. I don't know if you can see it, but layer-wise and consistency is actually the best one. I'm not going to go with the higher temperature because there are some discrepancy in the layers, and also I'm not going to go with lower temperatures because I can see some discrepancy in the corners right here. So 210 looks the best. And this is what we're going to type in the filament and save it. So let's click on our filament, and in the temperature, we're going to set it to 210 degrees. And here in print temperature, we're going to set it to 210 for first layer and other layers. And we're going to save it. We can ignore these values because those are recommended nozzle temperature, but this one are the printing temperatures. So we can close this and keep going with the calibration. So next up is max flow rate, and we can leave it as default, and let's check the wiki. This is the page from GitHub and it will explain everything about it. And it tells us that once printed, note where the lines begins to fail and where the quality begins to suffer. Pay attention to changes from matte to shiny as well. Using calipers or a ruler, measure the height of the print at that point. Use the following calculation to determine the correct max flow rate. Start plus height measured multiplied steps. For example, in the photo below and using the default settings value, the print quality began to suffer at 19 millimeters measured. So the calculation would be 5 plus 19 multiplies 0.5 or 13 millimeters square per second using the default values. Enter your number into the max volumetric speed value in the filament settings. And actually we can take a screenshot of this one so that we have it saved. Then we press OK and we can just repair and we can slice the plate. Also make sure that you change the color scheme to flow so we can see what the actual volumetric flow is in the print itself. And it will take 43 minutes. So let's change back to flow and let's print it. And here is the test with the max volumetric speed. I still need my magnifying glass to see because it's really hard to see the grain, especially with this bright light, but we should be able to see something right here. It is the sweet spot right there, and then we're going to measure it, but let's check on the other side. I would say on this side is right here. So let's get a set of calipers and measure, and let's see if the other side is the same height. So where the line is actually in good state and it's acceptable, we're going to measure on the other side and see if it's the same. 20.2, and on the other side, bear with me guys, I need my magnifying glass again just to be really sure. On this side is 21 and on the other side, let's measure it again. There is a spot where it's actually really low. It's actually 17. So I guess we have to go with this value because otherwise we're going to have problem with the max volumetric speed. So I would say on this spot right here, you can see some discrepancy. The lines are not really good. So I would say right there, maybe 18.5. I would say 18.5 sounds like a really good spot. On this side, it's higher. Yeah, probably like in the guide it says 19, which is a coincidence, but I would do 20 at this point because on this side the sweet spot is 21. Maybe I'll do 20.5. So now I'm going to go into the slicer and set that value and see what the new value is for the max volumetric speed. I just open a new file and I'm going to set the max volumetric speed using that formula that we saw before on the website, which was 5 plus the number we found multiplied 0.5. Our new formula will be 5 plus 20.5 multiplied 0.5. 20.5 multiplied 0.5. It's 10.25 plus 5. And this is going to be our max volumetric speed. Control C and set it right there. And I'm going to save my filament. Now what we can do to make it even better is to redo this calibration right here, the pressure advanced, which is the same calibration we did at the beginning, but I wanted to be really precise because I wasn't really super sure. Especially now that we have a new max volumetric speed, it's better to do so. So I'm going to go into calibration and then pressure advanced. And because I'm using a Bambu P1P, it's a direct drive. So I'm going to select that and I'm going to use the PA pattern as before, start PA 0 and the PA 0.08 and PA steps 0.005. And let's press OK. Now we're not seeing anything because we need to slice plate. This is just a visual representation, but we're going to slice it. So with our new max volumetric speed, I want to see if our flow ratio changes or not. Let's check. Now we should see our bed temperature going to 45 and the nozzle temperature to 210. Let's wait and see if this actually happens. And it's perfect. The bed is 45 degrees and the nozzle is 210. Let's see how it goes. And as you can see here, I was suspecting that the actual value was improved or changed. And in fact, now it's 0.02. But changing that value didn't affect the flow ratio, which is still 0.98. Let's leave it as it is and let's run a first layer test this time after all this calibration and let's compare them all. Alright, after all the calibration done, we can move away all the parts printed before calibration. Let's move them away and let's get the new ones printed after calibration. And first up is the calibration cube. Let's take a look at the surfaces, and we can see right here that the X on the top, there is no crack anymore and the surface looks way better. Same thing goes with the Y wall. Except the bottom right there, there's a little bit of imperfection, but I think that's because when I pulled the cube away, it kind of warped it a little bit, but the surface looks pretty good. And this is the X wall. Still the top is not super perfect, but it's workable. And then the bottom layer, the first layer, is actually pretty good. The top surface is not bad except that spot right there. I think, I don't know, the nozzle probably got in the way. But yeah, let's compare them before and after calibration. On the left, we have the cube before the calibration, and on the right, it's after the calibration. This is the Amazon Basic Filament. And yeah, the difference is pretty clear. The X looks cleaner, way cleaner. The overhang over there looks way better. There is no line indent on the top of the X. And let's check the Y-axis. The Y-axis is pretty much the same, just less noticeable. The line on top of the letter is less noticeable. So overall, it's a little bit better. And then the first layer, bottom layer, we can see those spaces between, on the left, between the lines, which is not great. But after all the calibration, look on the right, and we have almost a perfect layer. The top surface, I don't know, I'm not sure about it. It looks better line-wise, but there are some spots here and there. I think the nozzle was getting in the way somehow. I don't know why, but it looks a little better. I just moved things around because I was getting confused which one was first. On my left, right here, this part is before calibration, and on the right is after calibration. And let's compare the new string hell after the calibration. There is still no string in, which is a great news. But I would say that the top layer right there looks way better. Next up is the Orca cube with a little screw. So let's look at the surface first. The X wall looks pretty okay to me, and the Y wall as well. The Orca Slicer logo looks pretty good as well. But let's compare them. On the left before calibration and on the right after calibration. There's a slight difference, I would say better. It's improved, so it's a plus. For some reason, I think the left one looks better at the bottom, but better on the new one after calibration at the top. So if you move it like that, yeah. Let's check the logo before and after. It's definitely better, as you can see right there at the bottom of the logo where the round bed is. It's connected well. So let's check the text. The embedded text on the left before calibration, I mean, it's readable. And on the right, after calibration, it's definitely better. We can see the lines a little better and read the text, especially the C and the E and the S. They are way better. The top layer, let's check the top layer. Definitely the new one, after calibration, it's way better. You can see less imperfection. And now let's check the screw. So I'm just going to go. And yeah, it screws pretty much well, except the tip of it. But yeah, it's not too bad. It's definitely better than the other one, but would say usable. I would say not, but still pretty good. There you go. It's all in. Perfect. After the calibration, let's check one by one from bigger to small. 0.225. Perfect. 0.2. Perfect. 0.175. Perfect. 0.15. There's a little wiggle, so it's okay. And then 0.125. Still a little wiggle. 0.1. I suspect this is going to be tight. Slight wiggle. So hopefully, fingers crossed, at 0.075, we're going to get a pretty tight fit. And we do. That's it. The other one was actually stuck in the same spot. Before calibration, it was stuck completely. I cannot remove it unless if I use in my vise. But now, that's it. I'm not going to try 0.05 because it's not going to go in. It's going to get stuck literally at the beginning. Let's do the cylinder. 0.225. 0.225. 0.2. 0.175. 0.15. Okay. And then 0.125. 0.1, tight fit, and then 0.075. It's not gonna go in. It's super tight, but it's workable. I can remove it easily. And 0.0.5, I am not sure it's gonna go. It gets stuck, but it still moves. So you see, this is after calibration, it works. Let's move on. And this is the Orca Slicer tolerance test. Let's do the cube at 0.25, completely free, 0.2, perfect, 0.15, almost tight, 0.1, very tight, and then 0.05, I don't think we can get it in. In fact, it gets stuck. The other one before calibration was actually stuck at 0.1, like that. And this one, it gets stuck at 0.0.5, so that's a win. Let's go with the cylinder at 0.25, perfect, 0.2, 0.15, 0.1. It's almost super tight, but there is a little line over there for the seam, so I'm not sure. 0.0.5, we can get it in. And yeah, we can get it in and move it around. With the other one, we got stuck at 0.1. It's really, really tight at 0.1. Instead, with this one, we have clearance at 0.05, which is great. And now the number slider, after calibration, we can see the tiles. It's really, really workable. You can play with this one easy. They work really well. They're free. Let's check the surface. The bottom surface looks all right. Not perfect, but okay. And the top surface is perfect. Let's compare them side by side. So on my left, we have before calibration, and on my right, after calibration. We can see definitely a difference in the number. And the first layer, the bottom layer, you can see the lines are not perfect on the left before calibration and almost perfect on the right after calibration. And this is the first layer test after calibration. And as you can see, it's perfect. There are no holes, no imperfection. It's absolutely perfect. You can bend it, it doesn't break, it's perfect. Look, even under the light, there is no imperfection. Even better than the Bambu Lab, I would say. And we made it. We turned a cheap filament like an Amazon basic PLA into a premium filament like a Bambu Lab PLA filament. It was a journey, I would say, because it was really stressful, a lot of work to do, a lot of checks, a lot of mistakes made, but along the way, everything is positive because it's a learning process. I hope you enjoyed this video as much as I did making it, and if you did, please do consider to subscribe. If you're not, click the like button and leave a comment down below. If you have questions about the calibration process or anything else, please do let me know. One thing to consider for sure is to make sure you choose a filament that is good for your needs. What I did here was just buying a random PLA filament from Amazon, literally the Amazon basic brand, and test it first before I calibrated it, and I turned out to be right because it was terrible. We saw all the tests, it was horrible. But with a little effort and patience, if you calibrate a filament, absolutely you can get great results. One other really important thing to remember is to slow down your speeds just a tiny bit because these filaments are not made for high speed. And now if you excuse me, I'm really tired and I'm gonna eat some pasta. And as usual, I'll catch you in the next one.